So hello everyone and welcome back. In this video we are going to learn that how can we implement queue using structure and array. So let's begin. So first of all I will just create a file here and I will just name it as queue.c because I am just going to code in C programming, and then I am just going to include two header files, that is stdio.h and other is that is stdlib.h. After that I am going to create a structure and I am going to name it as queue because we are creating queue. Okay, so struct is the keyword, then the name of the structure is queue, and I will just open the two parentheses and I will just put a semicolon here to complete the structure. Now in this particular structure I am going to declare four variables, and those four variables are as follow. So first variable is basically size variable. It is going to store the size of queue, that is how many elements are going to be present in queue. Other than it I am just going to store one more variable or declare one more variable, and that is going to be front. It is going to store the index of the front part of the queue. Then I will be going declare one more variable, that is rear. It is going to store the rear index of queue, and one more pointer variable, that is star queue, and this particular pointer variable is going to be used by us to create array dynamically during runtime using concept of heap. Now I will write a function whose name would be create, and this create function would be helping us to create an queue from this structure. And this particular create function will consist of two arguments. One is an reference argument of type queue itself, and other is the size. So let me just write struct then queue, and I will be just writing star queue because I have to provide the reference argument. Now struct is to be written here, remember that. Okay, after that I am going to declare one more variable, and it is basically of type int, and it will be consisting of size. It will be storing the size of that is queue. Now I will basically initialize the front and rear to -1. Why? So let's have a look. So let me just move to whiteboard. So suppose that you have an that is queue prepared. Okay, queue is basically an array only, we all know that, and that particular array is a restricted array in which you can just enter from one side, that is you can enter element from one side and remove the element from other, as I have already explained to you. Now consider that this particular array is consisting of four elements. Okay, so 0, 1, 2 and 3 are the indexes. So initially the pointer, that is this rear and front pointer, are present at -1. We keep that at -1. The reason behind that is whenever we want to enter new element in the queue, we are basically entering element in the array itself. So it's basically easy for us to enter the element on the 0th index when we try to enter it through this particular index pointer, and therefore we keep them at -1. Okay, so I and j are basically first of all consisting the value -1. Now we all know that. Let me just make you understand that how can we, what is the logic behind entering this element in the queue. So suppose j is here basically doing the work of rear, and I is doing the work of front. Okay, so I have already explained that rear is used to insert element. So first of all I will point this j to the 0th index. Okay, and I will be doing this operation that a of j is equal to 1. So it is basically a of 0 is equal to 1. So 1 is going to be stored here. Similarly, if I want to enter one more element, then first of all I will be incrementing the index pointer, that is rear index pointer, and then I will be writing a of j is equal to 2. Now as I have already incremented, the value of j is basically 1 now. That is, it is pointing at the first index. Okay, so it is basically 2. Then one more element is added, so 3, and one more element is added and it is 4. So when you are basically entering all the elements, so the index at which the rear points is basically the latest index, that is the index of the latest element. Okay, so this is all about rear. Now this particular front is used for removal of element. So if you want to remove, then first of all you have to just point it to this, that is 0th index, and then you have to just remove the element. So I will just remove the element. Okay, This is how it works. And now front is basically storing the index as 0. Okay, so f is equal to I is equal to 0. That is, it is storing the index as 0. So this is how we insert and remove the element. I have already explained you in the previous video. The logic behind this particular whiteboard session was that why we keep ij as -1 initially. So let's move to the coding section once again. So in this particular function, I will be just initializing, that is q arrow function front is equal to q arrow function, then rar, and it is basically equal to -1. Then I will be basically that is initializing the size. So q arrow function size is equal to size. Okay, so size is here the size we get from the function, and q arrow function size is the size of q. Now what are we going to do is we are basically initializing the array, or say we can not initializing exactly, but we are giving the memory to the array. So let's just give the memory to the array. So q arrow function capital Q is equal to, I am just typecasting it using int star and then malloc function, and in that malloc function basically I have to write q arrow function then size into size of size of int. Okay, so this is how you allocate the memory. Now why is this particular thing written, that q arrow function size? So q arrow function is q arrow function size is basically the number of elements that we need to store in q. So number of elements into size of integer is basically the size of array. So this is the concept why we have used this particular formula. Now the other function that we are going to use is basically the enqueue function, and this particular enqueue function enqueue. Okay, so this particular enqueue function is going to used by us to insert element. So it basically consists of two arguments. So first argument is of a reference argument of type q only, so struct, then queue star q, and the other argument is basically the element that you want to enter. So first of all, what we are going to do is we will check if the queue is full or not. So how can we check if the queue is full or not? So we know that in case of queue, we can enter element from one side and we have to remove the element from the other side. Okay, so consider that you have an queue. Okay, consider that you have an queue present here. So let me just draw a queue, and suppose that I have four blocks, that is you can enter four elements, so size of this particular array is 4. Okay, so if I have this particular rar pointer here first, that is rar equal to -1 at initial, and 0 1 2 and 3 are the index. Now if I want to enter, then I will just point it towards 0, so rar is equal to 0 and I will enter 1. Then again rar is equal to, I will just increment the rar pointer and I will store, that is a of r is equal to 2. So it will be storing 2 3 and 4. So the process remains same. Okay, so now the value of rar, that is the rar is storing value equal to 3. So you can see that there is some relation between this rar and size of. So I can just say that q is full when the rar is present at the last, that is last block of the array. So what is the index of the last block? It is basically n minus 1, where n is the size of array. Okay, so what I am trying to say, that if rar is storing the value equal to n minus 1, where n is the size, that is n is equal to 4 minus 1, that is equal to 3. Okay, so you can just say that when rar equal to size minus 1, then the queue is full. So same concept is going to be applied by us. So let's move to the coding section once again. So if rar, so first of all I will write q arrow function rar is equal to q arrow function size minus 1, and you have to remember that you need to write equal to because we are basically comparing them. Okay, then I have to print something, and that printf is going to be print that q is full, queue is full. And if this is not the case, then I want to enter element, so I will just be entering the element, so I will write else. And so as to enter element, as I have already explained, that you increment the rar pointer by 1, that is q arrow function rar plus plus, and after that what you do is you enter that particular index in the array. So q arrow function capital Q, and I will just enter the index as q arrow function rare. Okay, and I will just assign this value as x, and x is nothing but the argument that is provided in the enqueue function, and I will put a semicolon here, and this is the end of enqueue function. Now you need to create one more function, that is dequeue function, and this dequeue function is going to return us or say pop out the element from the queue. So dequeue is the function's name, and this function is going to consist of consider an argument of type queue itself. So struct, then queue and star queue again, and first of all we are going to check if the queue is empty or not. So let's move to whiteboard again, and let's see what's the condition to check if queue is empty or not. So consider that this is our queue, okay, once again, and suppose that there are no elements present. Okay, so suppose that there is rare and there is a front pointer. So rare equal to front equal to -1 initially, as I have already explained to you. Now suppose you want to enter an element, so you are entering an element. Okay, so you will just point to the index and add an element. Then you want to enter one more element, you will point to the index and add one more element. Now suppose you want to remove the element, then logic is you will point to that index and then you are going to remove that element. Okay, so there is yet one more element present. So let's just again move to this pen. Okay, and the other logic is same again, that if you want to remove one more element, then you need to point to that index and then you just need to go to eraser and you just need to remove that element. So basically you can see that whenever r equal to f, that is if r and f are pointing at the same block, okay, then the queue is going to be empty because f is going to do the work of removal. Okay, so the condition for queue to be empty is rare equal to front. Okay, so let's apply the same condition. So if q arrow function rare is equal to q arrow function front, then I am going to print that q is empty. Okay, and if this is not the case, then what I want is I want to return something from this function. So I will just initialize x to -1, that is I will first declare x and initialize it to -1. And if the queue is not empty, then what I want to do is I want to just write an else statement, and what I'm going to do is I will just increment the front variable. As I already explained you that you want to remove, then you first point to the index of the element that you want to remove and then you remove the element. So I am just storing that removed element in this particular x. So x is equal to q arrow function, then capital Q, and in that index is q arrow function front. Okay, so this is the code and I will just return x. So this is the code to write dequeue function. Now I want to create one more function, that is display, and this display function is going to consist of argument of type call by value because I just want to display the value. So it would be just q, and what I am going to do is I will just declare an iterative variable, and for I is equal to q dot then front, then I is less than equal to q dot rare. Now you need to remember that you have to write q dot front plus 1. Why plus 1? Because initially it is present at -1, and if any element is not removed, then you have to basically point it to the 0th index. So q dot front plus 1. And if you even remove some element, okay, then as I explained you in the whiteboard session, sorry. So as I have explained you in the whiteboard session, that if you remove the element also, then the front is basically pointing at the empty space. So you cannot print empty space. It will just give you garbage value. So that is why you have to increment by 1. Okay. Now let's just move to the coding part again. And I will just give one more condition, sorry, one more increment value, that is I plus plus. And what I need to do is I want to print, and what do I want to print? I want to print the element that is present in the array. So I will write %d as it is basically an integer type array. Then I will just write this particular thing, and I will just give the value. Okay, and that value is basically q arrow function, capital Q of I. Okay, so this is how you can write that thing. Okay, and after that I will just move out of this function. Now I will create an int main, and it is not arrow function here because I have declared a call by value thing, so it is dot here. Okay, so you just need to remember that dot is present here. And now I will just move to int main, and in this int main I will be just writing, that is declaring an object of type structure. Okay, that is struct, then queue and q, and now I will be calling the functions. So first function is to create. So create, and I will just pass as call by value, sorry, reference type, so end q, and the size is basically 5. After that I will write enqueue function, and in that I will be passing the same argument, that is enqueue, because it is the same queue in which I want to enter the elements. So 1 is the element that is going to be entered by me. I will copy this and paste it for 5 times. Sorry. So this is the thing that I have done. I will just copy and paste it the following thing for 5 times, and after that I'm going to use the display function, and display function is called by value itself, so only q is going to be present, and I will just print using /n, that is new line, and I will be printing %d. Okay, and I will be writing that I will be calling that is dq function here. Okay, because I want to remove something, and the call by reference argument is only present, so end, and I will be giving the argument of q, and after that I will be closing by semicolon, and I will be returning 0 because it's an integer function and I want to return nothing. So this is the function that we have. I will be just storing this, and I will be just looking at it once again. So I think there is no error present yet. So let's just check that if our code is running successfully or not. So the code is been building, and let's just check our output. So it's basically debug console. So yes, 1 2 3 4 5 and 1 is present. So basically create function, then we have added 1 2 3 4 5. Display function is printing all the element from starting to end, and 1 is been removed because first in first out concept is the concept of queue. First element that you have entered is 1, and it is the element that is going to be removed. Now when you use this particular queue, okay, then there are some of the problems available. That is it is not of the purest form of queue that you can use, and we will check that how can we solve these problems in the next session. So I hope that you like this video. So like, share and subscribe, and if you have any doubts you can just move to the comment section. So have a good day.